Here's another U-substitution example, and this is example 3. And again, we're dealing with the antiderivative, so we have the antiderivative of x times the square root of x squared minus 5. And again, this is just if you just think of this, whatever's between these two symbols is what we're trying to find the antiderivative of, but it'd be a little more complicated. It is a little more complicated because of the chain rule involvement. We've got a composite function, we've got a square root, and we've got an x squared minus 5. So square root of something and x times something minus x squared, or something squared minus 5. So those are the two functions. So first of all, we'll write it, make it a little bit nicer. So we'll put the, and then we also, remember, we're going to try to get it in this form over here. So the antiderivative of u to the n, du equals u to the n plus 1 plus c. So I want to get an exponential form, so what I'll do is I'll rewrite this radical in exponential form. X squared minus 5, and that's going to be to the 1/2 power, that's the square root. And I'll move my x to the right, x dx, because that's going to be part of my building blocks for my du. Okay? So again, we look like we're moving along here, so we'll try to figure out where we're going to let u be. And u will be whatever is going to be raised to the power, and that's going to be x squared minus 5. So now I can just substitute in, and I have the integral of, instead of writing x squared minus 5, I can just write u to the 1/2. But I still have the x dx. So we want to get this to be du, u to the n du. Here we have u to the n dx plus other stuff. So let's see if we can find out what du is. So we'll just take the derivative of both sides. And this is going to be 2x dx. Now remember, it's really du dx equals 2x dx dx. And remember, differentials behave a lot like fractions, so you could just multiply it through by dx, or you could say dx over dx is 1, and then just multiply by dx. You're still going to get this, so it saves a little bit of time to do this. And it looks almost like a perfect match. We need x dx. We've got 2x dx, so how can we move the 2? Well, we'll just divide both sides by 2. And we have 1/2 du equals x dx. And now we have a perfect match. There's your x dx, there's your x dx. All right? So instead of writing x dx, I just write 1/2 du. So I have my integral over here, u to the 1/2, and then I've got 1/2 times du. Almost looks like u to the n du. I just have that 1/2, so I'll just put that in front using the constant multiplier rule. And now I have the integral of u to the 1/2 du, and you can see you got u to the n du. So that's just going to equal, now remember, don't forget the 1/2. And then we've got the integral, or the antiderivative, I should say. If we say integral, we see this, we're actually saying the indefinite integral, which is the antiderivative. U of u to the n du is just u to the n plus 1, so u, and what's 1/2 plus 1? Well, 1 is 2/2, so 1/2 plus 2/2 is 3/2, divided by 3/2. Some of you can skip this step and just multiply by 2/3 plus c, and that does indeed equal 1/2 times 2/3. And that's going to be u to the 3/2 plus c. Okay? And then this just becomes, and then 2 over 2 becomes 1. So we just have 1/3 or 3 in the denominator, so you can just write it with the 3 in the denominator. So we'll have u to the 3/2, And we have a 3 in the denominator, or you can multiply it by 1/3, however you want to write it, plus c. But what was my u? My u is x squared. Right up here you got it written down, x squared minus 5. So you just look up there and find out what u is. X squared minus 5. And you're done. So very easy as long as you follow all the steps.